In our unit of force, we're going to specifically talk now about the concept of friction. And before I describe, I'll give you an opportunity to write some information down. As you can see, friction is a force that is occurring when two surfaces are in contact with each other. Typically, we say that it's a force that opposes motion, but as we've learned during ice storms, we know that we need friction for an object to move. Car tires will continue to spin if there's not enough friction between the tire and the road. So not only does friction sometimes oppose motion, sometimes you have to have friction for objects to move forward. The two types of friction that we're going to deal with most are static friction, which is the friction between an object that is at rest, and kinetic friction, which is the friction between an object that's moving across a surface. To get an object moving, you have to overcome the static frictional force between that object and the surface. We denote F, capital F, lowercase f, and a little s to be the symbol for static friction. Once you get the object moving, the friction between that object and the surface that it's in contact with is called kinetic friction. The ratio of the frictional forces and the surface upon which the object is moving is called the coefficient of friction, and it's represented with the letter mu. It's a Greek letter. It looks like a U. Sometimes it looks like an M, but it is the Greek letter mu. And that represents the ratio between the friction of the object and the force that's applied from the surface that the object is moving on. Sometimes we can describe mu as being the ratio between the force that's being applied on an object and the weight of the object. So here's an example. Let's look at some rubber box that's trying to slide on dry concrete. When the object is sitting still, it has a coefficient of static friction of 0.9. A way to look at that is if the rubber object, had a weight of 100 newtons, it would take 90 newtons of force to get that object moving. However, once the object is moving, only approximately 70 newtons of force will be needed to keep it moving. That's what we call the kinetic coefficient of friction. So as you can see, it's a lot easier to keep something moving than it is to get something moving. We also have the formula of the frictional force is equal to the coefficient of friction times the normal force. The normal force in most of our scenarios is going to be equal to the weight force of the object. The normal force is the support force. So if a book is sitting on a table, the book pushes against the table, and the table provides the normal force against the book in an upward direction. Usually the weight force and the normal force are opposing forces. Here is a diagram that represents the four possible forces on an object. That object can be at rest or in motion. The sum of all the forces involved on this object is called the net force. In our conceptual physics class, the weight force and the normal force will be equal to each other, because many of the scenarios that we will be practicing do not have an object that has a vertical motion. It's not moving up or down. It's mainly sliding horizontally on some surface. So the normal force, which is the support force, and the weight force, provided by the gravitational attraction on the object, will be equal in all the examples that we'll discuss. However, the other two forces, the applied force, the push or the pull, and the friction forces may be equal, or they may be different. We'll look at several examples. Couple of things to consider. If the frictional force is greater than the applied force, the object is probably going to be slowing down. In other words, if you're pushing and the frictional force you're trying to push against is greater than the force that you're able to apply, then the object's going to slow down. If the two forces are equal, then one of two things is happening. Either A, the object will not be moving, that's what we call the static situation, or B, the object will be moving at a constant speed. It'll have an acceleration of 0, but it'll still have motion. That will be its kinetic friction. If the applied force is greater than the friction force, then you will be accelerating. The speed of the object will be increasing, and the frictional force will be less than the applied force. So let's look at a sample problem. Suppose you have an 8-kilogram box that's being pushed across the floor horizontally with a constant speed with a force, an applied force of 40 newtons. So here we have three things that we're going to try to do with this scenario. Draw what it looks like. Then we're going to look at all the forces involved. We know one's been given, so we're going to try to look at the other three. And then the third thing we're going to do is examine what is the coefficient of friction between the tile and the box. So we've got our box, has a mass of 8 kilograms. And the other thing we know is that there's a force applied of 40 newtons. So that's basically what's given. So what else is it that we need to know? Well, we can figure out what the weight force is. Because we know that weight is the mass of an object times gravity. So we take the mass and we multiply by gravity. And so we know the weight force is equal to 80 newtons. And because this object is not moving not moving vertically, we know that the normal force, and that N does not represent newtons, it represents normal force. The normal force is equal to the weight force, which means it also is equal to 80 newtons. Now, when it comes to the friction force, they didn't tell us what it is, but they gave us a clue. They said that the object is moving at a constant speed. Well, if the object is moving at a constant speed, that means our force applied and our friction force have to be the same. Anytime the acceleration of an object is 0, the friction force and the applied force are equal. So with that being said, now we know all of our forces. And the last thing that we are asked to do is to find out what is the coefficient of friction. The coefficient of friction was that funky letter mu. And to calculate the coefficient of friction, we take the friction force and we divide it by the normal force. All right. So our friction force was 40 newtons. Our normal force is 80 newtons. So that means our coefficient of friction is 0.5. Notice how the newtons will cancel out. So the coefficient of friction does not have a unit. It is a ratio. One way to look at this number is to basically see that it takes half as much force to push the object as is the weight of the object. So that coefficient of friction, and this happens to be a coefficient of kinetic friction because the object was moving at a constant speed. So this was a friction force that was kinetic, and this is a coefficient of kinetic friction. And that's how you solve these problems.